This is graphing proportional relationships, and we're going to start off with a key idea. So we want to create a graph that we can analyze when we're graphing proportional relationships. We can do that if we have a table. As long as we know which variable represents our independent variable and which is our dependent variable. Our independent variable is always going to go on the x-axis. So they've told us here our x value is going to be the time in seconds. Our dependent variable always goes on the y-axis, and this time we've been told that is going to be our height in meters. So we've taken these data points at 3 seconds, we're at 2 meters, and put them on our graph, over 3 up 2. At 6 seconds, we're at 4 meters, 6, 4. At 9 seconds, we're at 6 meters, and at 12 seconds, we're at 8 meters. And then I've connected these points in a line. I know that they were going to be in a line because I can see from the structure in this ratio table that this graph is going to have a constant rate of change. The x values are all going up by 3, while the y values are always going up by 2. That constant rate of change is what tells us this is going to be in a line. I also can see that this graph is going to pass through the origin, which is our 0, 0 point. The graph of every single proportional relationship is always a line through the origin. So since this graph is a line and it will pass through 0, 0, these two values represent a proportional relationship. So let's analyze some other data and see if that actually forms a proportional relationship. So in this case, I've been given 3 points, 2, 6. My x is 2 when my y is 6. 4, 8. And 6, 10. If I draw a line connecting these points, I notice that while it is a line, it does not go through the origin. It does not go through point 0, 0. So in this case, x and y are not in a proportional relationship. Let's take a look at this data. So I've got 1, 2, so 1 on the x-axis, 2 on the y, over 1 up 2, 2, 4, and 3, 6. So if I go ahead and graph these, they will go through the origin. So in this case, x and y are in a proportional relationship. We have a line through the origin. That tells us that these two pieces of data are in a proportional relationship. So here we have a graph of the Mars rover named Curiosity going at his top speed. So in seconds, the rover moves a specific amount of inches. So here we have a few data points that they've marked for us, and they want us to interpret the plotted points. So the first plotted one was at 0, 0, and the first 0 on the x-axis stands for time in seconds, and the second 0 stands for distance. So if I interpret this, I can basically say that this point means that the rover has traveled 0 inches in 0 seconds, which logically makes sense. Here we have 1, 1.5, which is our point right here. So over 1, so that's after 1 second, and the rover has traveled in distance 1.5 inches. So when I'm interpreting here, I would say that the rover has traveled 1.5 inches in 1 second. This also happens to be my unit rate. The rover can go 1.5 inches every single second that it's traveling. This point, 3, 4.5. This means that the rover traveled 4.5 inches in 3 seconds.